Hi there. I would like to tell you about a super useful tool called functions, which you can use to solve many problems, like quickly calculating how much you need to pay for bananas, or building a pyramid in Minecraft without a single click. By the end of this video, you should have some idea of what these functions are, how you can use them to solve problems, and how can you talk to other people using them. Also, at some point, you might encounter these collections of symbols which might look complicated, and the point of this video is to show you that they are not complicated at all and you should not be intimidated by them. To see why functions are so useful, I will show you one of the many problems they might help you solve. Imagine that you work for a banana selling guy who has a very weird price list. He wants you to charge 20 cents per banana, but for every triplet of bananas, he gives a discount of 10 cents. And, to make things even more complicated, for every 5 bananas, he charges extra 15 cents. So when someone comes to the shop and asks you for 7 bananas, how much do you charge him? Well, 20 cents for each banana gives 140, but there are 2 triplets of bananas, so you subtract 10 cents for each, giving 120 cents. But there's also 1 quintet of bananas, so we need to add 15 cents, giving the final price of 135 cents. As more and more customers go to your shop, you become quite annoyed because you have to do a lot of calculations. And you start wondering, isn't there an easier way to do this? Luckily for you, your next customer is a nice mathematician who sees how desperate you are and decides to help you. He thinks for a moment and then creates kind of a magic box for you. He says that if someone asks you for any number of bananas, like 15, you no longer need to calculate the price by hand. All you need to do is plug that number into that box and it will spit out the correct price for you. See how useful the box is? It saves you so much work, which is the reason why it is worth learning about it. These magic boxes that you put something in and they give you what you want are called functions, and they can do all kinds of stuff for you. But maybe you are thinking, wait, surely there are no magic boxes in the real world? Well, it's true that functions aren't physical magic boxes, but they are something that works like these magic boxes, and I will show you how that something could look. Here in this box, I have something which is not a physical magic box, but it does exactly what I talked about. When you want to know how much 7 bananas will cost, you don't have to calculate anything. You just plug in here into that box and press play. And it gives you the correct price of 7 bananas. It also works in cases when it is much more difficult to calculate the price of the bananas. Say, if you are interested in how much 1432 bananas will cost, you can just write the number there and press play. And you don't have to calculate anything. And here it gives you the correct price, like $281.60. That's really useful, isn't it? It saves you a lot of work. But that's not where it ends. This is just one function. You can build many more functions. For different problems, you can build different functions. Consider another problem. Imagine that someone came to you and said, hey, I have $4.20 and I want to buy as many bananas as I can. Well, how many bananas can I buy? You can try guessing different numbers of bananas and plugging it into our function that tells us how much these bananas will cost. So say you guess 30. Well, so let's see how much they cost. Oh, that's too much. So say 20. And you get it costs less than $4. Okay, let's see if you could buy more than 20 bananas. And you could. And what about 22 bananas? No, you can't. So obviously, here you can conclude that the guy with $4.20 can buy only 21 bananas. But that was, again, quite a lot of work to do. And again, you can cut that work by inventing a function that answers this question directly. And you can see it here. This is another magic box, another function. And I type there how many cents I have, $4.20. And it will give me how many bananas I can buy, 21. If I plugged in there like 0, I have no money, it will tell me that I can't buy anything. If I plug in the 135, for which we bought 7 bananas before, you get 7. So you see, you have another magic box which solves another problem. You have another function. Now that you know what functions are and what they can do for you, it's time to look at how you can build a function and how people talk about functions. Here, on the left side, there will be the scheme of what function is, and on the right side, there will be the usual representation of functions, which is how you encounter them in school and in the real world. As you saw, you can build different functions for different problems, and for that reason it is good to name your functions so that we know which function we are talking about. We can have a box function named how much it costs, or we can have a function named how many can I buy. The first one will tell us how much it costs, and the second one will tell us how many we can buy. But if we just ask how much it costs, there is no right answer to that. The price depends on something. It depends on the number of bananas we want to buy. This number we are putting to the box that specifies the output has a fancy name, a variable. Variable is the number that can vary, and the output of the function depends on it. For the function how much it costs, the variable is the number of bananas you want to buy. For the function how many can I buy, the variable is the amount of money you have. You write this by writing the name of the function, and to its right, you write the name of the variable its output depends on, and you write it inside brackets. For the how much it costs function, it looks like this. Here's the name, and here in the open brackets, there's the variable it depends on. And you could read it as this is a function how much it costs, and it depends on a variable, number of bananas. How do you think it would look for the function how many can I buy? Try it yourself. But how exactly do the outputs of these functions depend on their variables? Now we are getting to the interesting part, which is how do you build a function? Let's consider a really simple example for that. For the moment, forget about the weird pricing. Let's just think about a shop where you simply pay 20 cents per banana you buy, and you want to create a function to which you give the number of bananas you are buying and it gives you their price. You call the function how much it costs, and its value depends on the number of bananas. Now, its output is equal to the number of bananas times 20, because you pay 20 cents per each banana. So if you have 5 bananas, the value of the function, that is the output it will give you, is equal to 20 times 5, which is 100 cents. The process of creating a function like this is called defining the function, because we are just writing the receipt for calculating the value of the function from the value of the variable. But this is not the most common way functions are written. Generally, people are lazy and they want to write as little as possible. For that reason, most functions are called f and variables are called x. But that's completely arbitrary. You can call them whatever you want, but usually you will see functions written in these two ways. Here, in the first way, you have the function whose name is f, and it depends on variable x, and its output is equal to 20 times x. In the second case, there is some new thing, y. This y is a special label for the output. So you have label f for the name of the function, the name of the box, label x for the name of the variable, the thing you are putting to the box, and label y for the thing you are getting from that box. But these are arbitrary names, and you can call it more descriptively if you want to. If these symbols ever look complicated to you, don't worry, they still represent the intuitive concepts of magic boxes. By the way, if you are interested in building more complicated functions, I have made another video about that, but in this video I want to focus on what functions are and what you can do with them, so I will not talk about more examples of building other functions. Now that you have some idea of what functions are, why they are useful, and how they look in the real world, I want to show you a very useful way of visualizing functions. What I mean is when you had the how much it costs function, which told you how much you would pay for some number of bananas, you could visualize it in this way. Here there are two arrows, a horizontal one labeled number of bananas and a vertical one labeled price. And there's also a number of green points. Now, each of these green points represents what you get from the function if you give it a specific number. If you plug 1 to the function, that means you are buying 1 banana, it outputs 20. You see, here's the 1 banana we are buying, and here are the 20 cents you are paying for it. Now, if you plug in 7 for 7 bananas, well, it should output 135 as we saw, and that's exactly what it gives us. In general, you can find the output of the function for any given input in this way. You find a point that represents the input on the horizontal arrow, which people call x-axis. Then you draw a vertical line above that point to find where there is the point representing the function above the point. So you see there's the point that represents the function here above the input point. And then you draw a horizontal line which goes to the vertical arrow. Now the vertical arrow, which represents price, is often called y-axis. And you see that to the input 7, the corresponding output is price 135. Now, why is that important? Well, it's not necessarily important, but it's really, really useful, because in your shop, you no longer have to answer everybody how much they will pay. You can just hang this image on the wall and they can try to find it, and they can immediately see how much they will pay. Try it yourself. How much would you pay for 11 bananas? First, you find the input point you are interested in, which is here, 11 bananas. Then you draw a vertical line that goes to the function point, and that's here. And then you draw a horizontal line that intercepts with the axis representing price, and you get that the price of 11 bananas will be 220 cents. I also want to give you a more practical example of where you could use this kind of visualization. Imagine that you are thinking about storing $1 on your bank account with 4% interest rates, and you are wondering how much money will you have on that bank account over time. The way you could figure that out is to calculate it for like 1 year, 5 years, 10 years, and always calculate it for the time you are interested in. Or you could just look at this graph, and for every time you might wish to know how much money you will have on the bank account, you can immediately see it from that graph. So for example, how much money will you have on the bank account in 20 years? You first find on the input line the corresponding number, which is 20 years, and you draw the vertical line to the function, and from the intersection you draw a horizontal line which will intercept with the output axis with the y-axis, and you can see that you will have $2.2 in 20 years, and you can immediately see that say in 30 years you will have a bit more than $3. And you can see these things immediately, which is the reason why this visualization is very useful. And in this sense, one could argue that functions are a communication device because they very quickly convey information that would be hard to convey otherwise. To recap, I hope you have some basic idea of what function is. Essentially, it is a box to which you give something you know, and it gives you back something you want. They are very useful because they can help you solve problems, and also they can convey a lot of information. I hope that the next time you see something like this, which might look scary, you won't be afraid of it. You will realize that this is just some magic box named F to which you plug some T, and it will give you something back, and that something you can calculate using this receipt. Although you might not understand this receipt, you don't have to give up understanding what this function does, because every function solves a problem by answering some question, And even though you don't understand all the symbols in the receipt, you can always ask, what is the question this function is answering? And this particular function is answering how much money will you have on your bank account after t years if you start with $1 and you have 4% interest rate. So even though it might have looked complicated, you know what it does, you have already met it. The point is that even though these things might look complicated, they are not. You just have to ask what kind of questions they are answering. But what I really hope you are taking from here, if nothing else, is that the functions are really cool and it's so much worth learning about them.